Here is another communication question about sum and difference of two vectors. I hope you are enjoying this series of sum and difference. Now this one is C4. How is sum and difference of two vectors related? Well, you can answer this question in many different ways. In a way, all the questions which I am dealing with in this series can be helpful to provide the answer for this question. So you can kind of summarize your learnings from the previous and the coming questions on sum and difference out here. So it's kind of a very open question where you can write a lot, right? How is sum and difference of two vectors related? One, we can talk about, let's say, it's better to take an example, right? Let's say we are talking about two vectors, vector u and vector v, and the angle between them is theta. So this is what, let's say, these are two vectors, right? So in general, we will say, let this vector be u, and then let this vector be v, and the angle between them is theta. So that is what we are talking about. We are talking about a vector v here, and vector u and vector v, with angle in between as theta. So in that relation, we can discuss this problem. How is sum and difference of two vectors related? So one, we can say, well, the sum, let us say sum is u plus v. Sum, we are talking about magnitude at this time. U and v represents the sum of two vectors, the magnitude, okay, we are talking about. So when we are comparing, it is always the magnitude being compared. And that's the difference between the two vectors. Now, how are they related? So if we have different theta angles, let's say if theta is equals to, let's say acute, that means, let's start with 90 degrees. If theta is 90 degrees, then how are they related? If theta is less than 90 degrees, that means acute as shown here, then how are they related? And if theta is greater than 90 degrees, then how are they related? So that is one way of explaining this question, right? Correct? So that way we can say, well, if theta equals to 90 degrees, then they are equal, right? If theta is less than 90 degrees, a situation like this, then sum is much greater, right? So sum is greater in this case. But if theta is greater than 90, that means if I have a vector like this, then sum will be smaller. So in that case, sum is less than u minus v, right? So this is one way of doing it. The other way is you can find algebraically, right, the answer. How are sum and difference related? So in general, we know what is the sum of two vectors. If angle is theta between them, the sum of two angles is u square plus v square minus 2 u v cos of what? Write that down. And difference is almost the same thing, u square plus v square minus 2 u v cos of what? You will notice that when it is u minus v, it is always this angle theta, but when it is u plus v, then the angle actually is not theta. It is, when you do u minus v, then theta is this angle, right? Angle is phi, which is 180 degrees minus theta. That is the angle. So the angle here is not really theta. It is 180 degrees minus theta, right? That is the angle when it is sum. And can you tell me what is cos of 180 degrees minus theta equal to? It is equal to minus of cos theta. Do you understand? Minus of cos theta. Sometimes students will ask me, how do you know? So here is a recap. Cos 180 minus theta means you are somewhere here, right? Where theta is this angle. This is cos 180 minus theta. Now you know the cost rule. You know cosine is negative here, and if I'm trying to relate it with cos theta, since cosine is negative, it has to be minus of cos theta, correct? Minus of cos theta. And therefore, I can write this equation as u plus v equals to square root of all this, which is u square plus v square, but when it is minus, it becomes here plus. Let me draw this line also for u minus v. So it becomes plus 2 times u v cos of theta. Do you understand? So that makes a huge difference. This between plus and minus values. So that is how they are related. So you can use cosine law and then say, well, that is how their values will change. The magnitude of sum and difference really depends on the angle between them. If the angle is 90 degrees, then cos of theta, which is cos of 90 degrees, is 0. And therefore, you are not taking away or adding anything to u square and v square. So you get the same thing. Correct? But if theta is less than 90 degrees, then cos theta is positive. So you are always taking away. When you take away, then the difference becomes smaller. But in case theta is greater than 90 degrees, in that case, in second quadrant, cos theta is negative. It makes this positive. And u minus v becomes greater, right? Because you're adding something to it. So that is another way to explain the relation between u plus v magnitude and magnitude of difference of two vectors u and v, right? I hope that gives you a lot of information about this, right? So try to answer the next question and thereafter yourself. Thanks and all the best.